Howdy. Hello, I'm Jeffrey Snover, distinguished engineer and lead architect for Windows Server. And joining me is Rafat Issa.
Very nice to meet you. Rafat Issa, PM on the PowerShell team, program manager.
Excellent. So today we're going to talk to you about how to make your product manageable. So first we'll talk about motivation, right? Why do we care about manageability? Well, there's this story about the bank robber Willie Sutton, who when they finally caught him, they asked him, Willie, why did you rob banks? And his response was, because that's where the money is. That's where the money is when it comes to management, right, is in manageability, right? So if you take a look at what we see in the marketplace, we're seeing that manageability is increasingly the differentiator between product offerings. Okay? At the low end, products need to be simple and easy to use, right? Feature after feature after feature without manageability is not what these people are looking for. As you drive virtualization, boy, virtualization just drives scale, right? We've got these charts that show, that installed base, server shipments, over 8 million servers shipped every year. I saw something yesterday that expected that number of physical servers to double by 2015. You then add that to the install base, and that's a huge number. And then you add virtualization on that. And you have an IT department who are already, their hair's on fire trying to deal with stuff. And virtualization just pours gasoline on those poor guys. I mean, they're just barely able to cope. And so what they need is manageability. If your products aren't manageable, it just causes them exceeding pain, right? Because even a small problem, right? If you have a fly and it's near you and you whack it, that's one thing. But if you're in a jungle where there's flies everywhere, it can drive you crazy. And the point being that a small problem times a large frequency, like you'll get with virtualization, can just drive you crazy. So you got to have great manageability. And then what we're seeing is just as businesses go to cloud-oriented model, they're just trying to get operational excellence, where they are very agile, where they're very repeatable, and they minimize automation. They use automation to minimize errors and downtime and repeatability. Windows 8. So in the past, we have a bunch of great manageability things. We're not going to talk about those. We're going to talk about the new options for manageability starting in Windows 8. So we'll not talk about things like group policy or the ways you wrote WMI providers or PowerShell commandlets in the past. We're just going to talk to you about the new opportunities in Windows 8. And those are how to write a WMI v2 provider. Okay, there is a new way of doing this. It is wonderful. Let me gauge the room. Has anybody here ever tried to write a WMI provider? Okay, tough guys. Oh, good, good, good. Boy, are you guys in for a treat. Anybody written any code that consumes WMI? Okay, you guys want to stick around for the next session because that's going to be great too. So here we'll talk about how to write a WMI provider, dramatically different. There are new ways to write PowerShell commandlets. In version 1, you could write a PowerShell commandlet in .NET. That was it. In version 2, you could write it in .NET or in PowerShell script itself. And in version 3, you can write it in .NET, PowerShell, Windows Workflow, or SIM in WMI. And then lastly, we'll show you how you can configure a REST API using PowerShell and OData. A lot of times when people put these servers in clouds or in hosted data centers, they want to be able to be manageable by anybody, right? And in the cloud, the API du jour is a REST API. So how do I get that? And the answer now is we can show you how to easily configure that, to configure a REST API.
Using our PowerShell web API.
Thank you. Now, the new provider model is just dramatically simplified. We took a look and we said, hey, we do not see the amount of WMI providers that we think that we should. And frankly, it's too hard. And the ones that are there, there's not enough that are read-write, right, that you can actually do management. A lot of them, you can only do inventory. They're read-only providers. So we really wanted to address this situation. So we came up with a dramatically different model. One where you start off with a designer. You generate the MOF. MOF stands for Managed Object Format. It's a definition of the schema using a standard.
I didn't even know that.
You didn't know that?
No.
Well, here, there
Thank
you go. So yeah, MOF is Managed Object Format. It's a standard from the DMTF. And
I know what that stands for.
That is?
Distributed Management Task Force.
There you go, correct. So you start with that schema, and then you do this. We've got a command line interface. It's called Convert MOF to Provider. We take that schema, and we will dynamically generate a set of early bound C data structures, a template provider with all the methods filled out, and then little things that say, fill in your code here. We'll show you a sim designer that does that for you. You then go in there, right? So these bodies all then return not supported. You go there, fill in the bodies, and it's about an order of magnitude easier to write a WMI V2 provider than a V1 provider.
Right. So I'm just going to emphasize this point. The skeleton actually generates running code. Of course, because there's no business logic in the skeleton, it doesn't do much. It doesn't do anything, actually. But you can compile it. You can build it. You can actually register the provider. All you need to do is actually add the business logic.
Exactly. And we've extended it now. So that will give you just a generic WMI provider. But we've also provided a new library for your provider to call. If you've written a PowerShell commandlet, let me get a feel for that. How many of you have written PowerShell commandlets? Okay, so as you write a commandlet, there's a set of APIs like write output, write verbose, should progress, should continue. Well, when you write a WMI provider, now there's a C equivalent of those APIs that you call. And when you call those APIs and use a set of conventions for how to do this, we will automatically generate a PowerShell commandlet for you. So that's how you do that. All right? So that's why in your WMI provider, you can have things that do what if and confirm in your provider. Pretty crazy stuff.
We call that commandletization. So basically, you've written your WMI V2 provider, and you get almost PowerShell for free. You add the PowerShell semantics, the mapping, this method on that class or that object maps to this property in commandlet, and there you go. You basically define an XML file that does the mapping, and the PowerShell engine generates the proxy functions on the fly at runtime.
Yeah, and it's worth saying, you saw that there were over now 2,300 commandlets in Windows 8. That really comes from two things. One is this technology, the ability to generate these commandlets from native code. And the second is this guy. Rafat is the guy that darkened everyone's doorways and said, you must provide this. And people would say, well, we're very busy with this, this, and this. And he'd say, oh, thank you, I understand. You must do this. And he wouldn't leave until they came. And he's put incredible amount of effort. This is the guy you want to thank for the great PowerShell coverage in Windows 8. Okay, so let's show it. Let's have some fun. Okay, this is Visual Studio. I'm going to start with a new project. This new project is the is the Sim IDE.
You mentioned the plugin, Snap-in that they need to know?
That's what I'm doing.
Oh, okay. Sorry.
So you got
Go ahead.
sentence ahead
Go
of
for
me.
it.
So there is a new plugin to Visual Studio called the Sim IDE. This is available today on Code Gallery.
Absolutely.
On Code Gallery. That allows you these two new types of projects. Sim authoring project, where you define your metadata, and a sim provider project, where you implement the metadata, you implement the provider behind that. So let's implement the authoring project, and we'll call this MSFT Win Service.
Jeffrey skipped the first one. The first one, we've basically imported the entire MOF schema, 1,500 classes. I don't think you want to do that. But if that's what you're looking for, then you can do it. He chose to import just the immediate parents of the classes he wants to import from.
Okay, so now this brought in a set of classes. I'm now going to import some schema that in WMI, you typically start with existing schema and you either implement it or you subclass it to make your own. So what I'm going to do is bring in just the schema required for me to implement my own. Rafat, where is
your Solution Explorer?
Where is that?
Your Solution Explorer is here. Right there, Control.
Thank you.
Yes, you're welcome.
Okay, so I grab those MOF files and I bring them in as references, and then you see this gets expanded out here. I'm then going to pick the class that I'm going to subclass. I add a subclass, in this case MSFT underbar Win service. This is my build demo. And when I view the code, this is the MOF. So we now have syntax highlighting for the MOF. You'd go in here, you'd add your properties, etc. We actually have that done, so I'm going to do the Julia Child trick. Copy. Paste, but I'll highlight what we're showing. So this MOF, you shouldn't be afraid of this MOF. This is pretty simple stuff. It is the DMTF standard, so that's why it looks a little different than the typical way we do things. But you've got a class service, that's subclass, see the colon off that thing. You've got a string and it's got a name, and you've got these attributes, and these are DMTF attributes, or what they call qualifiers. So we're going to have a name, a caption, a startup type. Look, we've got mappings, 2, 3, and 4 map to automatic, manual, and disabled, right? So you get it. And then we've got two methods, a start method and a stop method, okay? So that is our schema. And now what we're going to do is we're going to provide a provider. Save that. And we're going to add a provider. We add a new project. And here we're going to have a provider that implements that. And that's going to be the MSFT Win Service Provider. Okay. So that then generates provider class, a bunch of source files. Sorry, it doesn't have the source files. I now go to the schema, and there's a button up here that says Generate Code. And what we're doing, get rid of the SAL annotations and the Boolean qualifiers. Now this will take a while. We're reflecting against that. We're compiling that MOF file, looking at that schema, and then dynamically generating all the C data structures in order to implement these, so they're early bound data structures, and a template provider, and we're generating the source code for that. And when we're done, we'll open that up, and here it is.
Take a look at the...
Oh, I got the wrong one.
MSFT, so yep.
Sorry. I got the wrong one again. Here we go. Okay, so this is what that looks like. Here's the enumerate instances class, and you see we define the structure, we check the parameters, and then we post a not supported. And so you see we've got all the things necessary to implement this class. Now again, I'm going to do the Julia Child trick and get that provider. And we'll go through the code in a second, but first let's build it. Make sure it's going to work. Okay. And then, excellent. So now let's take a look at some of the code to get this in focus. So enumerate instances. Okay, so this is going to get all the Win services stuff. So we open up the Service Control Manager, and we get a bunch of stuff here that's all error handling, but this is the meat of it. We take the object, we've got these early bound methods that we generated for you, and what this does is it sets the status. Here's where you set the startup type, you set the name, you set the caption, and then you post this you post it as a result. And if you had any problems, notice here, no problems. You have write verbose. So remember that as APIs, which are isomorphic to the command line APIs. Okay? So now we've generated that provider, a DLL. I'm going to copy that provider to a temp directory. Oops. Should probably execute it, not delete it. That means I put it in a different place. Okay, get rid of the dash, get rid of the dash. Did I do that right? Okay, so let's see if that works. Okay, there, we copied it, and now we've now provided that we started with the schema, we generated a template, we filled out that template, and now we got to register that. So we register it, successfully registered, and now I can do things like get that class that I just defined, MSFT service. I can do a get sim class on it, and there it is. See its properties. And its methods. And if I want to get it, here I get a sim, I ask for this thing.
Jeffrey, their monitor, I think, is. Can you see all the way to the left, or is it chopped off at the left? It's chopped off if you just want to move your window a little bit to the right. Their left is chopped off. Yeah, and here as well. So this is what they see.
Ah, sorry. How's that? Yeah, okay, sorry. Now I'll get a sim instance. I'll get all the sim instances. I'll sort them caption and format it as a table. Okay, so that's all my sim stuff. So pretty simple stuff, okay? But now notice I'm doing things like get sim class and get sim instance, okay? Here, what I'm going to show you is that there's something called commandletization XML. That's some XML schema that basically says, here's how to map that WMI provider to a PowerShell class. And we've now overridden the import module. Import module can now accept one of these things. And when I do that, and I import it, I've got to give it the right place. When I do that, import module. When I import that, notice, I now get win service, start win service, stop win service, and some aliases. If I do get help on get win service, right? We get the help for that. I can get win service by name, by status, or startup type. And then I can do things like get win service minus name, audio service. We see that it's running, so I can say stop name, win service, minus name, audio service, minus confirm. Do I really want to stop it? Yes. Check it again. It's now stopped. What? Go ahead and start it. Check it again. And it's running. So here's what we showed you. We have a brand new way to write WMI v2 providers. It's about an order of magnitude easier. We have a new plugin, the SimStudio plugin, SimIDE plugin to Visual Studio. You start with that. You define your schema. We have syntax highlighting for the MOFs. You fill that in. You can then create a provider for the sim provider. You then, for that schema, you can take the MOF, generate that code. We produce a bunch of early bound templates that you then fill in. There's a lot, when you fill them in, there's a library that gives you PowerShell semantics. We then create that DLL. We register it with WMI. And with that, you can then go do all the great WMI stuff. It opens you up to the full WMI ecosystem of tools. You know, things like System Center, HP, all that great stuff can go access that stuff. And the generic PowerShell commandlets. If you then add some metadata schema, the CDM XML, then it describes how to map that class into a PowerShell commandlet. And when we imported that as a module, now I'm able to get all that information as a commandlet, invoke that, etc. Now, the great thing about this is that that can work on other people's machines. That CDM XML could talk about a SimOm on a Linux box or on a hardware box. And we don't have to get any code from them, and we can get commandlets running on Windows that will then go talk to them. Because what we do is we take that CDM XML and we generate proxy functions to go talk to it. So this is how we're trying to take Windows and make it a cloud management operating system, being able to manage anything by leveraging standards.
Cool.
Great. All right, so why do we do this, right? Well, we have this chicken and egg problem, right? And why manageability is important and how we're going to try and address this chicken and egg problem. This is as follows, right? Managed elements, people produce stuff, they in general don't deliver customer value, right? Management solutions do. So if I go produce, Intel had a great example of this. Intel with their vPro chip, right, invested gazillion dollars in their vPro chip, made available on a bunch of their desktops and laptops, and that vPro chip didn't provide any value to customers. It was only management solutions that took advantage of that provided value to customers. But the problem with that was Intel had to get those management solutions to support it. And then the customers had to adopt those management solutions. So that was tough. And then those management solutions, when people like Intel come to us and say, hey, we want you to support our chip, solutions vendors don't do that until there's market share. And so there's the chicken and egg problem, right? The managed elements don't get the market share until they're unique solutions. Well, PowerShell actually fixes this, and vPro is a perfect example. vPro had that situation, or Intel had that problem with vPro. They got it out there, and there's some great press, and people loved it. They loved the promise, and so they bought a bunch of that, paid a premium for machines that had that, and then there weren't the management solution support that gave them value for it. So they basically had this round where people said, well, next round, I'm not sure I'm going to buy that. What vPro did was they produced a set of PowerShell commandlets, and they went back to those customers and said, hey, look, you can directly access our management through PowerShell. Let me show you how to do it. Customers said, that's great, I love it. And they do love it. And so now they get value from that. So now the customer gets value from the managed elements by leveraging PowerShell. That gives them the support, and then all of a sudden it's up to management solutions to either meet that, do better than that, or sort of become irrelevant. Because hey, if the customer can get the value out of that managed element and more than you're providing, why am I paying you money? So it helps solve this chicken and egg problem.
It also helps abstract the problem. I don't have to know a lot about vPro. If I have the commandlets, I can manage vPro. If another hardware vendor actually comes up with something similar to that, I can use identical or similar commandlets without knowing a lot about what's lying underneath.
Yeah, right, because you might start off with start vPro computer, and then when something else comes out, you say start X computer. You can provide an abstraction that says just start computer, that underneath the covers calls one or the other. That's a great point. So we have something called the Windows Management Framework. The Windows Management Framework is really that was the thing, if you saw in my keynote demo, that the Server Manager is a thin layer on top of this, the Windows Management Framework. It's PowerShell, WMI, WS Management, and it's really designed to minimize the cost to make your product manageable, and maximizes the value of doing that. Having made your stuff manageable, we want you to feel like you got a fantastic deal for it, right? Customers get value, they get remoting, etc. And this is what enables our goal of getting rid of GUIs off of servers. So that was the talk we had just before this. The preferred configuration for Windows 8 servers is to be server core, right? No GUI on it. And the way we get no GUI on it is by having full and complete manageability, and then taking GUIs. Let's be clear, we love management GUIs. We love rich management GUIs. Just run them on clients, not on servers. We don't want anything on servers. We want those rich management GUIs to leverage the Windows Management Framework to access your manageability, PowerShell or WMI, over remote protocols, WSMan. So this is an example of the end-by-end problem, right? Where you got IT pros, developers, solution providers that need to go manage things, and then you got stuff at the bottom, right? People who talk to disks, storage, Exchange devices, your elements, and how's that work, right? So, in the past there were, well, here's a set of APIs to go talk to storage, and well, here's a set of APIs to talk to networking, and here's a set of APIs to cause SQL, right? And that was just a mess. Right now I want to provide a comprehensive management solution, and I got to learn all this stuff. It's just a nightmare.
It takes an enormous amount of time, delays shipping, and requires more resources and a lot of money.
Yeah, or if you provide your stuff at the bottom, how are you going to get people to pay attention to you?
I exist.
Yeah, exactly. And you say, well, like vPro, they had to go try and get everybody to support their stuff. Well, the Windows Management Solution, Windows Management Framework solves this, right? We solve this by transforming. That's actually one of the great definitions of an architecture. Architecture is that which transforms an n-by-n problem into an n-by-1 problem, right? So all the manageability stuff plugs into the Windows Management Framework. All the solutions consume the Windows Management Framework, and they can all talk to each other. So the benefits of this is, look, with PowerShell version 1, a bunch of people wrote commandlets, and they were happy. They thought that was a great deal. PowerShell version 2 came along, and they got remoting for free. Boy, they thought they got a great deal in version 1. Version 2, they get full remoting. In PowerShell version 3, the same commandlets are going to get automation, workflow, a ton of extra features, etc. And all the products on the top. System Center consumes this stuff. They're able to consume all the stuff underneath it. HP, etc. Everybody that consumes it, the more stuff that goes at the bottom, the better the products at the top get. The better the products at the top get, everything under the bottom gives more value. So that's what we're doing here.
Yeah. vPro would have been one of those purple boxes at the bottom. Intel.
Exactly. So this is what I like to call the big animal picture of the Windows Management Framework components. At the bottom is the messy world. The messy world. I mean, the world has always been messy. It is messy. It always will be messy. That's because there's existing implementations. We want to drive to a set of standards. That's great. There are often multiple standards. And things are innovating very, very rapidly and aren't following standards. So at the bottom, you always have a messy world, and you have a messy way to access it, locally or remotely. But then we bring that into our uniform layer. We have our engines, which are WMI, PowerShell, and Workflow. And then we make it uniformly accessible through web protocols, HTTP and HTTPS, through WSMan, a DMTF standard remoting protocol, and then OData, a REST API. Okay? And then here we're showing at the top that then remote tools can then manage things, whether it's our server manager, again, very thin layer, or PowerShell, PowerShell ISE, or remote other people's tools. Orange means other people's.
Power GUI, for example.
Yeah, Superstar Power GUI. Yeah, I don't know if you're familiar with Power GUI.
Power GUI's in the room. Dimitri's in the room. That's right.
Dimitri here. Stand up, Dimitri.
Get up, please.
Dimitri is the chief architect of Power GUI, a fantastic graphical interface that allows you to basically create, allows IT pros to create GUIs that consume PowerShell, right? So he did that, and guess what? Anybody who wrote a commandlet, they got a GUI because of Dimitri. They didn't have to do any work. Dimitri's work made their manageability a ton better. Now we've gone and invested. We've now produced 2,300 plus commandlets in Windows 8. Dimitri's tool, its value just skyrocketed because there's so much more to deal with. So that's what we mean. We focus in.
Oh, cool.
Wow, so for the recording, what you're saying was that the vPro guys, in fact, took his tool and produced a vPro Power Pack for it. A Power Pack basically transforms a set of PowerShell commandlets into a GUI. So, yeah, that's a great story.
Very nice.
All right, so writing a workflow commandlet, now I mentioned that we showed you how you can write a commandlet in WMI. And the benefits of that is you get all the PowerShell ecosystem, and you get the very large WMI ecosystem, System Center, et cetera, all that great stuff. All that stuff, you get both those. So now you can also write commandlets in Workflow, Windows Workflow. So you can use a Workflow Designer tool, if you're familiar with that.
What's the benefit of Workflow over a regular commandlet?
Workflows over commandlet. Well, there's workflows, commandlets, and scripts. Workflows are really for long-running operations that can run across time, okay, and across multiple machines. So imagine I'm going to perform an operation on this machine. I could choose to do it as a commandlet, or I could choose to do it as a workflow. Well, what's the difference? Well, as a commandlet, it's going to work or it's going to fail. And if it fails, what then? And with a commandlet, the answer is, well, try it again. With a workflow, what you can do is you can say, hey, I want to perform this operation on that machine, and if it doesn't succeed, you have troubles connecting to it, wait this period of time and try again and keep trying. So you might say, hey, I want to do this to that machine. It might be down, it might be in a state, whatever, and keep trying
might
for
be lost or something.
Yeah, keep trying for 5 days if you need to. Try every hour to 5 days. Or I want to perform a set of operations across a set of machines. That's where workflow really shines. Here's the reality. PowerShell's awesome, but when I went out into the field and saw what people were really doing with PowerShell, absolutely everybody who is standing up a service, a cloud service, etc., 100% of them were automating with PowerShell. They love PowerShell, and they were taking PowerShell and workflow and putting it together. Well, you don't have to be too smart to figure out what the next thing to do is. Because what happened was when they did that, they had to make hundreds of design decisions, and they'd make them differently. And when they made them differently, then the artifacts that they produced, the workflows, would only work for their implementation, and they wouldn't work for anyone else's implementation. And so what we did is, so basically they've got a broken ecosystem. So by taking PowerShell and workflow and bringing them together, we fix that. We define how to do those. We have the definitive implementation for how to bring those two technologies together so that anybody can host it, extend it, do their own value-added features, but the artifacts that get produced for anyone's implementation will work in anyone else's. That's our value. So you can produce these with a workflow designer. There's quite a few out there, or with PowerShell itself. And with PowerShell itself, you write it like a function, but instead of the word function, you write the word workflow. And then the syntax is the same, but the semantics are different. One of the differences in semantics is that in workflow, after every single line, you can stop the machine, reboot the machine, come back up, and continue on. Okay, so what that means is if you say $x equals get process, you can reboot the machine and then execute the next line. Well, obviously, having serialized, you have to serialize what the $x is and reserialize it so you have pure dead objects. Okay, so when you write workflows, you can never invoke methods on the workflows. Now, if you want to invoke methods, you can do what we call a script island, which says from here to here, execute as a PowerShell script, and don't serialize between every step. But other than that, you can reboot the machine between every step. It's really quite a wonderful thing.
Sounds like a script with a bookmark.
It's exactly right. And because of the bookmarks, you have to have different semantics. Oh, well, this actually answers your question. Why workflow? These complex production environments, they can get very complex, especially at scale. And so what this does is it helps long-running activities across multiple machines, deals with failures, and deals with machine interrupts. Again, I like to say, if you want to say do A, then B, then C, can B be reboot the computer? And when the answer is, yeah, it has to be reboot the computer, you definitely need workflow, because that's what workflow does. And so the point is that complexity has to be dealt with. And so if workflow doesn't do it, then the user has to do it. Well, who wants to do that, right? And if you're relying upon the general population, right, the bell curve of humanity to manage your stuff correctly, well, there's a good chance that that's not always going to work out as well as you want it to. Instead, you use this technology, which is intrinsically robust, and then you can hand that off to just a wide range of skill sets, and they're all going to get it right. That's why this is such an important technology. Okay, so here's an example of a workflow. What I'm trying to show here is, imagine you wanted to do an install 80 replication server, and this just sort of gives you the feel for this. So imagine the first step is I want to set up an operating system, and then CN means computer name. So imagine you want to set up an operating system on 2 machines, and then the next step is you want to patch those machines, and you might want to perform that on a scheduled basis. You want to patch it now, and you want to patch it every Tuesday, right? So you want to set up a scheduled task. Then you want to install Active Directory domain service, but only on one machine, not both. Then you run DC promo on it, install DNS, and then replicate that machine from one to another. Each one of those things, oh, sorry, in the middle one there, the DC promo, that's an asynchronous task. You're going to go off and you're going to wait for it to complete, and then you're going to continue on. At each step, you can see this is actually going to take a long time, and various things can go wrong. This is a prime candidate for a workflow technology. So you might ask, well, hey, what does integrating PowerShell and workflow together bring to us? And this chart basically shows you the capabilities that you get with workflow, the capabilities that you get with PowerShell script, and then the capabilities that you get when you put them together. And I'll leave it for you to read the details, but the answer is, you know, chocolate, peanut butter, put them together, tasty, tasty. Really good stuff.
We're going to see some of that in the demo coming up.
Yeah, and it's why so many people did it, right? I mean, there's a reason why. And when you see everyone that you care about doing something the same way, you got to say, hey, there's something going on here. Okay. Now, when you take a regular workflow, like the example, how many people saw my keynote demo? Anybody? Okay, so you saw, it looked like a function, and it just had, it had a parameter, computer name, and it had a name. In fact, when you take, it's leveraging the wonderful architecture of PowerShell, we take that function, and whereas you've only defined one parameter, we give it all these other parameters. Because PowerShell is at its core a hosting engine. And so when you have that command line and you specify any of these parameters, the engine provides that for the function. And so you see you can do things as a job, run things remotely, set up how to connect to machines, how frequently to do things, whether you want to persist the information, what credentials to use. Just an extraordinarily rich set of features that you can control how and where and when something gets executed.
There's that retry count and retry interval as well.
Yeah.
All right. I'm just going to show you real quick what the Workflow Designer can do with PowerShell. So is anybody here familiar with the Workflow Designer in Visual Studio? Yeah. So we're just going to start a new project. I'm a keyboard person.
And just so you're aware, there are multiple workflow designers. This is just one of them.
So we're going to create a C# project, a workflow project, and we're going to choose activity library. I'm not even going to bother renaming it. We're just going to create a blank project. I want to show you a couple of things once it comes back. There we go. You'll notice that the toolbox will have PowerShell-specific activity sections. I want to show you how to add one of these. You'll notice that there's going to be PowerShell core, PowerShell management activities, and we're going to add a PowerShell security activities as well. We just basically go in and add a tab to the toolbox, call it something meaningful. I don't know, PowerShell. I can hardly see that. .security. .activities, and excuse my typing. And we right-click on the newly created tab and say choose items. It took me a long time to remember what it was, but it seems so intuitive. So we'll go to Windows. Windows, Microsoft.NET, Assembly, GAC, MSIL, and we type in Microsoft.PowerShell.security, and this is what we're looking for. We want to pick the activities. We pick the activities. Sure enough, that's the version. And we include it in our section. We go to the bottom, and there's a new section. These are PowerShell-specific security activities.
So these are formerly known as commandlets, which have been transformed into workflow activities.
Correct.
Perfect.
Thank you. Yes. And as activities, they have properties that you can set. And we're going to do that right now. We're just going to create a very simple sequence. Again, this is just a proof of concept. We're going to do, how about get WMI object? Get WMI object. And for properties, let's just choose a class name of Win32 computer system, BIOS. Anything in particular?
Computer system.
Computer system.
That'd be fun.
And there's nothing to compile. This is just XAML, pure XAML. What we do is save. So we save. Right? Where's my Solution Explorer? Solution Explorer. Here I'm just going to copy and paste the path. Go back to the ISE, CD, and we're there. If you notice, there's a XAML file there called activity1. What we can do with PowerShell in this release is basically import that XAML. We're going to import it as a module. When you say import module,
by the way, how many people are familiar with XAML as a GUI concept? Okay, yeah.
Oh,
well, me too. And so, if you're not familiar with this, XAML is in fact just a generalized object serialization language. So, in fact, what this does is, when applied to workflow, it just has a different set of objects that get serialized. You don't see any buttons. You don't see any this. What you see is, sequences and state diagrams, etc. Did you have a comment or question? Yes, correct.
So let's say you're doing a workflow which is more than just using each PowerShell command. You might find yourself in a scenario that you want to use some C# on the side or do something more complicated. So what then?
Yes, so he's pointing out that XAML has some limitations, and so a number of those limitations, like code activities, et cetera, that you can't put into XAML, those are some of the benefits of the PowerShell approach where you can do some of those things. And just to be clear, it's because in PowerShell, ultimately we render things to XAML. And you could do all those things, it's just actually hard to do them. And so it's actually a little bit more easy to do in PowerShell. And what you do is we have what's called a script island, and which says, hey, from here to here, I want you to run this as script. In that, you can do anything you want. The whole thing is a distinct activity. You can include C# code right there, compile it on the fly, execute it, and then go do the next step. Actually, we're going to show some of that. Well, not the C# code, but.
so we're going to import our XAML. Let's do it verbose. And sure enough, it actually talks about a function called activity1. Let's run it and see what happens.
Do you really have blue on black?
I didn't choose it.
Oh, my Lord. Human factors have proven that is
This is a
metaphysically.
preview release. This is a preview release. Blue on black is a side effect of that,
Okay.
I guess.
It's metaphysically the hardest thing for a human to be able to discern.
Blue on black?
Yes.
So that's it. That was the GetWMI Win32 computer system. And that was just a very quick introduction to what you can do. You can design your XAML in Visual Studio. Whatever XAML comes out, you can import it as a PowerShell module. That was me?
Yeah.
Sorry about that. You can import the XAML as a PowerShell module, and you have your proxy function. Jeffrey is going to show us something else first.
So activity 1, look at that. So these are all the parameters that you can perform on activity 1, right? So you say, oh boy, why did you go through all that effort just to get the computer system name? Well, first he showed a very simple thing. In general, what you're doing is you're stitching these things across multiple steps, and you'd have flows and graphs and parallelism. But even for a single commandlet, you show
That's for
off.
command. Yeah.
Explain to them what you just did. One
This
of
is
the great
just-
new features.
So yeah, it is one of the greatest new features.
One of Rafat's great
please.
new features.
So this is basically, Jeffrey was just showing you the syntax diagram, and I felt sorry for you. So I felt just giving you a little taste of what's coming. Show command basically takes a commandlet and allows an IT pro to enter, instead of at the command line PowerShell syntax, to fill out something like a web form with checkboxes for booleans and switch parameters, drop-downs for enumerations, and validate sets.
You cannot use variables. Nope, I know. Yeah, so...
It's a good discovery tool.
Yeah. So this is all the things that you can do on that object, right? So you can run it here, there, specify a computer name, specify it as a job, run it with a different set of credentials, run it on that machine over this port to this environment, etc. Just extremely rich for just a little bit of work. By the way, just to get this one more in focus, because that's not a particularly interesting one, show command, what's a good one? Get process.
Set PS breakpoint. Try set PS breakpoint.
Yeah?
Set PS breakpoint.
Oh yeah, that's right. That is a good one. PS breakpoint. So here it's showing you the parameter sets. So a parameter set is a set of parameters, and set PS breakpoint has line, command, and variable parameter sets. And so you can say, oh, here's the script, here's the line, here's a column, or for a particular command, in the script, do commands name this, or for the script, which variables, and do you want to do it when it's variables read, when it's read, written, or read-write. So you can see how this new show command makes it easier to discover the capabilities of your commandlets. Again, back to the economics, this is now provided. Everyone who's written a commandlet in the past will benefit from this.
Yeah. It shows required parameters as well with an asterisk, easy to spot. With the syntax tree, it was a bit hard to just go through it and figure out which was required and which was not.
Great. So for those of you that missed my keynote demo, this is the new command line, this is the new server manager environment. This thing is entirely built, it's a thin layer entirely built upon the Windows Management Framework, and in particular, PowerShell, WMI, and Windows Workflow. So whenever let's go to here, I do this. Manage, I want to add roles and features. Here, if we don't have a chance to talk about it, but we have scenario-based deployment. In fact, this is probably the best example. We have scenario-based deployment, and for things like RDS, let's do a standard deployment, okay? And you can set up a virtual desktop environment. Anyway, I haven't run this one. I'm not even sure if it works. But what you do is you say, hey, in RDS deployment, right, there are different roles, right? There's the gateway role, the terminal service role, the connection broker, et cetera. And you can say, hey, I want this role to run on this machine, this role to run on these 5 machines, this role to run on these 3 machines. You can configure that, and when you say make it go, obviously this is done using workflow technology. You go do these long-running operations, installations, across multiple machines where the machines may or may not be up, eventually want it to work, and you sequence them all. So a ton of the stuff that you see here is all built upon the Windows Management Framework. Now the other thing I wanted to highlight was, we'll go back here, choose a different path. I pick a particular machine. Notice I can install to a virtual disk if I want to. So you can now do deployments to VHDs. I won't do that. I'll do it from this server. I can pick a set of things to install. I will not pick that one. I can pick a set of things to install, including now features as well as roles and role services. Yeah? And when I'm done, I can export this to a file. Okay, so now we've exported that to a file. And you see this is the XML file that contains all the information necessary to do that deployment. Why is that interesting? And the answer is, using the amazing show command.
Lucio's show command. He's our dev lead for this feature. It's his baby. Just echoing what Jeffrey was saying earlier about the thin layer on top, everything you see in Server Manager that Jeffrey's demoing and all the other things have an exact equivalent in commandlets. Play around with, first of all, import the Server Manager module and play around with install Windows feature, get Windows feature, and you can do anything you have to do, click in the GUI, you can actually do in PowerShell commandlets. because the GUI was built on top of them.
So this is the show command for install Windows feature. And you see the different parameter sets, and one of those parameter sets is configuration file. So here you can specify that configuration file, whether you want it to go to a VHD or to a computer or a set of computers, what credentials you want to use, and when you're done, whether you want to restart it or not. So it's pretty darn wonderful stuff. Now the example I showed was this is a workflow. Now if this was a function, this is how you type it. Right? That's a function. What's the difference between a workflow and a function? And the answer is that. Okay? Now, the individual commandlets here, the individual steps, this is the way you specify parameters. You get information into it. And the individual steps are scripts themselves, okay? And what we're doing is say we want it to run on these computers. So we have a for loop for each parallel computer and computer name. Run this script on that. Then run web deploy, et cetera, et cetera. The individual scripts themselves, back to the question, was this is just pure PowerShell. So anything you can do in PowerShell, you can do here. And in PowerShell, you can compile C# code. You can embed C# code directly here. You can do p-invokes to native code. You do that, and everything within this PowerShell script gets run as a single activity. It succeeds or it fails. Right? There's no stopping things. This workflow, you can run this and then suspend the workflow. And when this line's done, it suspends. You can then resume it today, tomorrow, next week, whenever you want, and it'll go and execute this, and it'll go, and if you can suspend it and resume it continually. Okay? Now, what we're also showing here is that this is running, so again, we have this install PS, let's see. I'll do it from here. Import module. You know what? We're running out of time. If you saw my workflow demo at the session, at the keynote, that's what I was going to show here. But basically, I was going to show an example of how I can invoke this, specify multiple computer names, and because I've specified that I want this parallel, these activities will go off in parallel. And what I did was a deployment of a web server, IIS front end, deployed a website, tested that website, and said, yes, it was good. Did that as a parallel activity across two machines. The time it took to do 2, I could have done 20 or 200 in the same amount of time. That's the power of workflow. And if I'm doing 200, you're guaranteed some of those are going to fail. And so because it's workflow, I can say, retry this many times over this period of time. And we will go the ones that succeed, great. The other ones, it will just keep trying and trying and trying until it's eventually there. So if that machine's disconnected, somebody took the wire out, or it's down for maintenance or whatever, as soon as it's back up, we'll retry again, and it will succeed.
So I think Jeffrey touched upon many of the points about why implement commandlets, the whole ecosystem idea. But concretely, what will the IT pro gain? All the cool stuff that you saw, whether it's show command, whether it's even Power GUI, all of these, the very basic building block to make any interactive IT pro experience rich are the commandlets. And not just the interactive experience, but also the scripting experience. From a very simple script, a few line script, to one of the most sophisticated workflows, multi-machine workflows that Jeffrey was just describing. The developer story is that, and this is actually going to be a demo in the next session if you guys will attend the next session. From a developer perspective, the managed.NET API allows you to consume commandlets locally, remotely, on multiple machines, and not just commandlets. It's almost identical how you can consume commandlets, applications, scripts, workflows. That's going to be in the next session. Commandlets are hostable in IIS for cloud service management. And when commandlets are coupled with REST and WSMan, you allow non-Windows platforms. I actually had a demo for this session running on a phone, on a Windows phone. But for some reason, the endpoint, the REST endpoint, decided not to talk to my phone a couple of days ago. So
We should skip to the REST stuff because
Sure.
we're out of time.
Let's do that. The next REST demo, just a quick overview of REST. It's the web API of choice. It is an architecture that relies on request response. HTTP rings a bell. HTTP is one of the most famous implementations of REST. It allows CRUD operations, create, read, update, and delete. Over HTTP, it allows data encryption using JSON and XML. We'll actually see in the demo how we use the browser to access the REST endpoint. The Open Data Protocol defines conventions for implementing REST. We're going to see an example of dollar metadata and how to filter on the URI. This enables rich tools, Power Pivot for Excel 2010, SQL Server's integration services. These are examples of rich tools that can actually just point to an endpoint, say, hey, what can you do? Give me some data.
Yeah, I don't know if you've ever programmed against a REST API. It can be a bit of a dog's breakfast experience. OData is a REST API. It is merely a set of best practices and conventions that allow the programming experience to be much smoother, much better, and allow tools to go and reflect against it to produce even better experiences.
And the PowerShell Web API, I have to get used to that. It's a new name, so I have to get used to it. Is the REST API two sets of PowerShell commandlets. And the mapping is pretty interesting. So basically, on the REST endpoint, you have PowerShell commandlets. They mapped to the SIM model. That SIM model maps to REST resources. We'll actually see an example of that in the demo as well.
And if you're not familiar with SIM, SIM is another DMTF standard. It is what WMI is. It's the WMI data model. WMI is what's called a SIMMOM, a SIM object model. So basically, this is saying we map PowerShell into a WMI data model and then project that through a REST API.
Right. And I'm very happy to report that a few hours ago, our colleagues back in Redmond actually succeeded in uploading the SDK sample that we're going to actually showcase now onto MSDN. The tool didn't make it quite yet, but the 3 links are here. We know where the tool is going to be when it finally is uploaded, but you can actually, anything you'll see in the demo, you can actually just go ahead and download hopefully in a couple of days. So let's switch to the demo. What I've done on the demo machine, just to give you an idea of what we're going to see. I've downloaded the SDK and I've run the setup. The setup basically installs IIS, runs DISM. That's what you're going to be running. So when you're going to download the sample, this is the role-based sample. There's a basic plugin and there's a role-based plugin. The difference is basically RBAC, role-based access control. The one we're going to do is role-based, and you will have to run setup endpoint. I'm going to run the quick version of that, which is setup endpoint quick. Okay? What this does is just set up the REST endpoint. IIS has already been installed, everything's been done. And in fact, the project has already been compiled. So we're just going to wait for it to finish. There we go. Documentation is going to be available with the tool as well. I just hope we can get to the tool. Okay, we go to IE, paste in. This is basically the hyperlink that appears at the end of the script.
That's the service endpoint. The service endpoint basically describes what's surfaced by that OData endpoint. This is why it's better than just a generic REST endpoint.
This is RBAC. It's asking me who I am. I'm local admin. By the way, the RBAC XML file in the sample has 2 groups, an admin group and a non-admin group. So this is one of the admins on the...
Where RBAC is role-based authentication.
Role-based access control?
Access control, thank you.
There we go. So this is basically looking at the OData endpoint. These are the REST, the managed elements exposed through the REST API. A process object, a service object. This is what I have access to. This is what I have been given access to. And in the demo, we're going to see how we can, for example, expose a NetAdapter object to be managed through REST. But before we do that, we actually skim through the slide. Here are some of the conventions that OData defines. $metadata, for example, gives you a whole slew of metadata about the managed objects.
Tells you what the objects are, what their properties are, etc.
Yep. And one of the things you can do as well is do simple queries at the query string, at the command line. So you can do things like service, and here's, I think, a filter already. You can say $filter, service name equals WinRM, and hopefully this will only return the WinRM object.
Hopefully.
Sure enough.
I bet your job it only does. So this is that joke about it's the programming in your browser model. I mean, you just type these URLs and you get the objects, you can perform operations on them in the browser. That's obviously not the way you want to do it, but you can. That's the whole cool thing about a REST API. It's very discoverable, very loose, very quick.
All right, and in IIS, click. This is the OData service endpoint, and we're just going to explore that. And I want to point to 3 files. This is the RBAC configuration file I was telling you about. This is where a non-admin group and an admin group are configured, and these commandlets are going to be exposed to users of the respective groups. So non-admin groups will not be able to see things like enable PS remoting, disable PS remoting, and test WSMan.
Just to highlight this, again, what we're doing here is we're saying this is a developer service. Developers such as yourself who want to make your stuff manageable to other people will use this service to configure which of your commandlets, or which of anybody's commandlets, you want to expose to who. You will run our tools and we will generate the REST API for you, and then people will program against it. So basically it's a way to make you be superstars by just simple configuration.
And this is the XML file. This is the mapping file. Remember we said there's mapping that's happening. PowerShell commandlets on the REST endpoint are mapped to the SIM data model, and the SIM is mapped to the REST resources. And here's where this mapping happens. The service object is mapped to the well, this is the old name. Yep. Service class, and so on and so forth, right? This is where the PowerShell mapping happens. This is the MOF file that defines the SIM model. So here we're looking at the two classes, service and process. It has the name of the properties for each class. It says which one is the key, and it says the data type for each property as well. And that's the MOF file. Those are the 3 key files that define the following. If we forget the RBAC for a second, then the schema.mof and the schema.xml define what the users will see. The RBAC on top of that, for role-based scenarios, defines who can see what. So you have pretty much very good control over that.
Yeah, it's also worth noting that in the past, hardcore developers could do these role-based authentication projections of PowerShell to people. That's what Exchange does when they run Exchange up in the cloud. With PowerShell version 3 and Windows Server 8, now IT pros can do that themselves. IT pros can set up an endpoint that has run as credentials as admin and an ACL that allow different people who don't have administrative privileges to run a small set of commandlets with admin privileges, just the ones that they want.
Exactly. You have full control over what you expose.
So we should switch.
I want to show them the tool. Oh, you want to switch back? Okay.
We're almost done.
Let me 30 seconds. I'm not going to show. Here's the tool. You can actually download it and play around with it. Writing them off and the XML is not easy. It's not fun. But we're actually providing you with a tool that generates both from a rich GUI.
Yeah.
So download it and play around with it. It's very powerful. I'm going to switch back.
Great. Okay, so this is our call to action. If you have your managed elements are native code, the call to action is to implement SIM standard schema. Use our new simplified provider model. It's available. It's available. Sorry, new provider model, use our guidelines and our extension SDK, and you get PowerShell commandlets for free. If you have managed code, implement PowerShell commandlets. It's the easiest to produce. You have your widest range of choices. If you have a non-Windows device, then we say implement SIM. By the way, how many people have non-Windows devices, things that need to get managed? Nobody. Oh, one.
Oh.
Okay, well, for you. So we say implement WSMan and SIM, and then our extensions, which we will define, and if you have SMIS, do it for storage. But if you implement WMI and SIM, then our commandlets will work that. We will document the extensions so you can participate in this thing where any Windows box in the world can point to your SIM provider and generate proxy commandlets to your object. So it's really quite a good deal. And we didn't talk about it? We didn't talk about it? Good Lord, I thought we were going to talk about it. Okay, well, I'm just going to talk about it. Additionally, right, Windows 8, I mentioned to you where it's a cloud OS, right? Cloud, best optimized for cloud OS. Part of that is leveraging standards-based management. We have had a major investment in standards-based management. You've seen just a small portion of it here. We are so invested in standards-based management, that's how we want to manage everything. We want to manage external storage devices. We want to manage networking devices. We want to manage hardware devices. We want to manage phones. We want to manage everything through standards-based management. There's a problem. Those other companies don't have very good SIMOMs, right? There are some open source SIMOMs. Honestly, they're not that good. And so put your seatbelts on, Microsoft has invested and written a implementation of SIMOM that's a portable implementation, first ran on Linux, and we're going to be making that available to the community, freely available. We're working with the lawyers to work out exactly how, but it'll be readily licensable by anyone. And this thing is fast, and small, right? The design center was to run on, well, I took my phone off because I'm presenting, run on phones. OpenPegasus is what a lot of people use. It's 76 times faster than OpenPegasus. So this is just a hot rod. And again, why? We're investing in Linux code, and the answer is we want the community to get on standards-based management. So it's an exciting time for Windows Server. We've gone from being kind of rough to manage to really, just world-class management in this release. So thank you.
Thank you very much.